Hello everyone, welcome back to the 5-Minute Tech channel. Today we'll be talking about secure coding, understanding and mitigating the OWASP top 10 issues or vulnerabilities, as we can say. So this is a critical guide to building a robust secure applications which can pass any security scans and make your production application without any security flaws. So introduction to OWASP, the Open Web Application Security Project as we call it, or OWASP is a non-profit foundation. You can go to their website to check more details, which is again owasp.org in the image, and that works to improve the security of the software. Their top 10 is a widely recognized standard that represents the most critical security risks to the web applications. Understanding and addressing these risks is important for protecting your user and your data in your web application. They also have regulations or top 10s for API and other areas, but we'll be concentrating on the web application. Now they have released an updated top 10 in 2021. Before in 2017 they were a different list, and they updated it to the latest standard and the technology stack. Based on that, they have updated on 2021. So you can see there is a change in the ordering as well as the clustering of the issues. The first issue, which is very important for a developer to be aware of, is broken access control. Now this vulnerability occurs when an application doesn't properly enforce restriction on what authenticated users can do, which areas they can go and perform actions. Now attackers can exploit this to gain unauthorized access to the functionality or the data in the application. Now example scenario is imagine an application where a regular user can access an admin panel by simply changing the URL parameter, and that could be a very difficult situation for the security of the application. Now this is the insecure versus secure comparison. On the left hand side you are seeing a vulnerable broken access control code in which the get user profile method takes an ID, and an attacker logged in as a user 123 can just change the URL to API/user/124 and steal the user 124's profile data. The code will never be checking anything as which user is it or who's making the request, something like that. Whereas if you see the secure coding on the right hand side, which is where we have tried to fix it, and the fix is simple but it is kind of critical, wherein we first authorize the endpoint, and then second, instead of trusting an ID from the URL, we get the user's ID directly from their authentication claims. This way a user can only ever retrieve their own profile. So this is the secure practice which we need to figure out to follow to fix this broken access control issue in our application. Next is cryptographic failures. This category covers a broad range of issues related to the inadequate protection of sensitive data through weak or improperly implemented cryptography. This can expose sensitive data like password, financial information, or personal details which we are processing in our web application. Now, storing user password in plain text or using outdated, easily crackable encryption algorithm is a root cause or example scenario. And then we will go on to the code. For example, the cryptographic failure. In this one, this was formerly called as the sensitive data exposure issue, and it means that you are either not encrypting your sensitive data at all, or you are using a weak, outdated, or poorly implemented encryption. In this example, you can see the registered user is trying to pass the password as a plain text to the object and passing it to the database, whereas the secure part on the right hand side, you can see we are trying to secure it to never store the passwords, and you can store the cryptographic hash preferred with a salt in ASP.NET Core Identities User Manager, and this is where it handles this for you without any plain password saving area. It uses a strong one-way hashing algorithm. Even if the database is stolen, attackers only get the hashes, which are incredibly difficult and slow to crack. So that's why you will be able to secure your accesses or authorization area. The third one is the injection flaw, such as the SQL injection. It is pretty famous, and most of devs know about it. There is a SQL injection, no SQL injection, or OS command injection occur when untrusted data is sent to an interpreter as a part of the command or the query. Now this allows the attacker to trick the interpreter into executing unintended commands. A login form that doesn't properly sanitize user input allows an attacker to inject malicious the SQL queries to bypass the authentication. Now the left hand side has the insecure code, wherein you have a login and you are just passing the string password into the SQL query, and by building the SQL query string by hand, the attacker can log in, and anybody without a password, they can just type something like and 1 equal to 1 or anything similar to that into the username field, and the database executes it, and the query logs them in as the first user in the table, which is often the admin. Or it can even cause some more problems, like you can delete the data itself. Now fixes always use parameterized queries. As we know, we can pass the SQL parameters. You provide the query template and then provide the user input as parameter. The database engine is smart enough to know that the parameter values are just data, not commands. And even better, we can use a LinkU ORM like EF Core or its LinkU queries to parameterize the inputs which we are having. So this is about how to securely write the code for fixing SQL injections or similar kind of injections. Now next is the insecure design. This is a new category in OWASP 2021, and it emphasizes the importance of secure design principles and threat modeling before writing code. Now flaws in the design itself can lead to several vulnerabilities, and an example, designed with without a proper segregation of duties, allowing a single user to perform multiple sensitive operations, can cause major issues in the application. Now this is a new category, and it's a huge one, because you are trying to make multiple users accountable for their actions, and it is not a single line of bad code, but it's about the fundamental flaw which can trigger in an application. Now it's about failing to think like an attacker during the design phase. A great example, a forget password feature. In secure design, you ask a username, and if it exists, you say password reset mail cell. If it doesn't, you say error user not found. Now what is the flaw? The attacker can use this feature to enumerate your entire user list, and they can just keep trying usernames until they get the emails and password and confirm a valid account. Now this is the secure design area would be, you always show the same generic message. If an account exists with that email exists, you will get the password. Now this reveals nothing to the attacker, and you have no single code fix there. The fix is to threat model your application, and we will have a separate session on threat modeling very soon. Before you write a feature, you ask how would an attacker abuse this feature, and that's how you draw the line on understanding what are security areas you need to plug. Next is a security misconfiguration. This refers to improperly configured security setting across various layers of an application. It includes the operating system, web server, database, frameworks, and custom code. An example scenario for this is the default accounts with unchanged password, unnecessary services enabled, or incorrect file permission. Now insecure code in the left hand side, if you can see, it's like insecure default settings, unpatched software, or accidentally exposing sensitive information. And this includes running in debug mode in production and not changing the default admin password for the database, and enabling the directory browsing on your web stack. So that's how you can probably cause a security misconfiguration. Whereas on the right hand side, if you see, you have the environment mentioned, wherein you can use the developer exception page, or you will use the production ready exception pages. Next one is vulnerable and outdated component. An application often rely on third-party libraries, especially in Node.js application, wherein we have frameworks and other software components written in JavaScript and other parts which we just pull down and we just use it. If these components have known vulnerabilities, which they tend to do, and are not updated, the entire application becomes vulnerable. Now, using an old version of JavaScript library, as I mentioned, with known XSS vulnerabilities can be an example scenario here. Now, insecure versus secure, this is more of a coding practice, wherein when you get the package, you audit it, you regularly use it in Visual Studio Tools or the run.NET List package vulnerable in your terminal, and this will check your project dependencies against the database of known vulnerabilities. And also in our enterprise system, you will definitely have your Artifactory, where the system scans those and then only it reaches your Artifactory. You can pull only from the Artifactory rather than from the net, so that will keep your system secure. And you keep updating your security updates, applying the security updates into your IDE and other areas, and use SCA tools for larger projects. Use software composition analysis tools like GitHub Dependabot, Snyk is some scanning tool, or OWASP dependency check, which can automate this and alert you. Now, tools like this Dependabot, which will literally open a pull request for you to fix the vulnerability, and definitely there is no excuse around this area. Now, identification and authentication failure. This covers weakness in authentication and session management. Attackers can exploit these flaws and to assume the identity of other users. Weak password policy, insecure session ID, or multi-factor authentication not being properly enforced can cause this issue. Now, insecure versus secure. Insecure side, this category is all about providing who you are and what you're saying that you are, and you are truly that, and what happens when that process fails. This includes allowing brute force attacks, weak password policy, insecure session management, and not having MFA in your system. And by configuring identity through ASP.NET Core Identity or any other identity setup which we have in your application, you can get all this out of the box. Strong password policy, account lockout, secure HTTPS cookie based session management that protects against these kind of thefts. And also you can easily add the multi-factor authentication. The eighth one is the software and data integrity failures. This is a new category again in 2021, which focuses on protecting against code and infrastructure integrity violations. It's about ensuring critical data and code haven't been tampered with. It's about example being not verifying the integrity of software updates, leading to malicious code being installed in your application or the server. And this is an example wherein you have a software update is the first example, where downloading an update or plugin without checking its digital signature, and attacker could give you malicious update instead. And the second one is insecure deserialization. Here in the example, we are trying to deserialize the application object, which is not in a very secure manner. Whereas in the secure code, if you can see, this is in the secure area, we fix is to never trust the type of user input. We do not trust from it. Always deserialize into a simple known object type like a DTO. And this way you only populate the safe properties you expect, and any malicious data is totally ignored. The ninth one is security logging and monitoring failures. Insufficient logging and monitoring can hide active attacks. Without proper logs, you will not be able to detect, escalate, or respond to security incident. Becomes incredibly difficult to or impossible to isolate it. Not logging failed login attempts make it impossible to detect. Brute force attack is an example. Now this is an example wherein we are not having any proper logging in system in the left hand side, and wherein in the right hand side you use a logging framework like Serilog or the built-in iLogger also, which logs important events, especially the failures, and then feeds that log into the tool like your monitor Splunk or ELK stack, and sets up the alerts on high failure events. Last but not the least, we have server-side request forgery, which is SSRF, which comes very frequently in any scanning tool, being it Veracode or Fortify or your Snake. The SSRF flaw occurs when a web application fetches a remote resource without validating user-supplied URL, and this can allow an attacker to make a server itself send requests to arbitrary domain, potentially accessing internal resources. So more of like an impersonation and trying to access the server resources. An application allowing user to input a URL for an image to be processed but not restricting that URL to external public resources. Now this is an example where an attacker can use this to scan internal network ports or access cloud metadata. So this is the left hand side is the code which can lead to SSRF attack. You have created a HTTP client, you are awaiting a response, and then you are just reading as a byte array async, and that is the file content which is image or JPEG. This is the tricky one, but it is kind of a dangerous, wherein server side SSRF is when an attacker can make your server send request to a URL that they choose. Your server lives inside your private system, and it is behind the firewall, and the malicious user can access things which they are not supposed to access. And on the safe side, on the secure side, the fix is validation. You must never trust a user supplied URL. Pass the URL and check it against the allowed list of known safe hosts. As an extra defense, resolve the DNS to make sure the IP address is in the private range. So this is more all about OWASP top 10. Hope you liked the video and found it informative. If you like the video, press like and subscribe to the channel. Have a nice day.